comes the question of allergenicity. Any protein can potentially cause allergy. So what is allergy? Allergy is a process where certain sequences in the protein are recognized by the body's immune system as a foreign protein, and then it stimulates an IgE response. It's called an allergenic antibody response, and we develop either rashes, or we'll get a stomach upset, or sometimes in severe forms allergy, like for example penicillin allergy. There are many instances where when you inject penicillin, the fellow drops dead because you are allergic to the particular protein. And there are also people who are allergic to peanut protein. There are people who are allergic to milk protein. There are many children who are allergic to egg protein. So there, all over, wherever there is allergy, it's a protein which is involved. So when we insert a gene, what does the gene do? It produces a protein. Essentially, it is producing the Bt protein. So we would like to know, therefore, whether the protein can cause allergy or not. Unfortunately, we don't have an animal model for allergy. In 2006, when the regulation came, we had one test which used a rat called as the brown Norway rats. Brown Norway rats used to come from Australia and New Zealand, and these rats are supposed to be a model for allergy. So even in our toxicological studies, we took a lot of trouble to import brown Norway rats from Australia. But later on, it was found that these brown Norway rats are not models of human allergy. Allergy is so specific to an individual that for the same material, you may be allergic, I have no allergy. So the question of a rat predicting a human allergy does not arise. And therefore, people have given up using an animal model for allergy. Instead, they use a series of tests which act as surrogate markers for allergy. So these tests are given in this International Food Biotechnology Committee ILSI document, and also the FAO WHO guidelines on how do you do these allergen tests. Number one, of course, is to look at the amino acid sequence homology with any allergen from the database. Now, as I told you, the peanut protein can cause allergy, egg protein can cause allergy, and any number of proteins are there which cause allergy. The amino acid sequences of all these proteins are documented in a database. There are something like 50,000 known allergens on earth. Many things, some of them may be plant, some may be an insect bite. So in the insect bites, what happens? You get a big bump, right? That bump occurs because insect injected its saliva, and that saliva had a protein, and that protein caused a skin allergy. So that is how we start scratching. Sometimes when you are going out in the shrubs, some plants may rub against you. Then you start itching because some protein from the plant went into your skin. Though all those proteins people have identified and documented every day. If you go to Allergome database, if you register on it, you will keep getting emails. Every other day, the Allergome database will say a new allergen has been found. So you have about 1 lakh or so allergens in the database, and every allergen's amino acid sequence is given. So you have your Bt protein or any protein which came out of a genetic modification, you know its amino acid sequence, and then put it on a computer software and compare those sequences with your protein sequences with known allergen database and see if it is matching. And that matching is done like this. Let us say your chain of amino acid has got about 50 amino acids. Okay? It will first take amino acid 1 to amino acid 8 and then run it through all the 50,000 to 1 lakh known sequences and see does it match anywhere. It doesn't match. Then it takes amino acid 2 to 9, 3 to 10. Like that, in a sequential manner, the entire 50 odd amino acids will be examined in segments of 8 with a known database, and if there is a match anywhere, that particular protein, that particular GMO will not go to the next step. There are many instances in the process of GMO. We are only seeing the success stories. If any company has brought in a particular event today, it must have gone through several hundreds of them and discarded many like this, if they were to match with it. There are many sequences are matched with shrimp proteins in the seafood which can cause allergy, and it has been found that some of the genes which are inserted in the plant produce proteins which matched with this shrimp allergen. and therefore such genetic modifications were discarded. You should actually have more than 35% of your amino acid sequence should match with a known allergen. Only then you discard it. If less than that, it is considered as a non-specific match.